Oh, I can see you now. Oh, hi folks, how it's going? It's a whole lot of you. I don't feel like that, but at least you can you can see me well, right? So, okay, I see. Mm-hmm. Uh, so it's the smallest I can make it. I will be showing all kinds of stuff to you, so okay. So let's try to make it this way. If it wouldn't work, then we'll try something else. Okay, so apparently, like last time I was covering continuous integration and continuous delivery, and also I was supposed to give you a brief introduction into the clouds and platform as a service. So does anyone in the room volunteers to uh, tell me a bit like why there is so much fuss about continuous integration and continuous delivery? Have you ever thought about it? Does anyone have any idea? Go ahead, shoot. Yep, go ahead. Uh, this is correct. That this is part of the truth, actually. The thing is that the pace of change has increased that much over the last 10 years that you basically have to, sometimes you have to build, test, and deliver prototype like over the weekend and do it like this is your buddy uh, from the university, because at Monday you have the meeting with the venture capitalists who will either get you funding or not. And except the two pager of like list of the features of your application, you don't have anything. Um, and like basically you have to start from scratch and build and deliver very fast. In the corporate environment, it happens also. Like very often you have to like you are expected to build a feature in a couple of days, test it and deliver it, and have it make it available to your customers. And this is like, if you think about it, this is crazy. Like in the old days, you typically had like couple of weeks to, without much hassle, describe your feature, document it, write code, then hand it over to testers who will on their leisure time test it, and then hand over to the ops people who will hopefully deploy it in the next month. Now kind of you have to deploy in 2 days. And apparently you don't want to do it like with your hands. Well, I sure hope you don't want to do it with your hands, because like in my early days, I was always doing everything by myself. I was running my very own Linux distro with my own Linux kernel of my make, uh, built for the very specific workstation of my own make. And like, I don't know, couple of months of effort into building this configuration. And then on top of that, I was investing like 1 week of time uh, every month maintaining it. And as I grew older, it's not fun for me anymore. I'd rather be in Brooklyn and have the cup of coffee and still be very productive and deliver things, deliver these features like every 1 or 2 days as the business wants them. Wow, that was cool. Okay, so and then we talk about like how do we do that? This is then we start talking about Jenkins and AWS. It actually doesn't matter what you will use. You can use Travis and Azure, or you can use like GitLab and let's say Cloud Foundry. Doesn't matter. It means kind of CI/CD and one of the clouds. Yes, I can't hear a word from what you are saying. Can't hear anything. Okay. Can someone go hunt these guys? This is the drill. It's crazy. Can you put yourself on mute in the meantime? Oh, way better. I still hope you can hear me. Okay, so I trust by this time you already met the small util which is called make, which is producing. Uh, by the way, kind of, I still want to have some kind of interaction with you. So if you will feel like asking a question or making a suggestions, just raise the hand and, oh, okay. Tirupal says he will write the chat. I sure hope you can still hear me from this drill thing. Okay, and if you still have questions or something like that, so tell them to Nirupam and he will post me them through the chat. Okay then, so you already encountered make by this time, I believe, which is like incredibly useful in eliminating this extremely boring thing of like you have to process then you have to take your C files through the preprocessor and then produce object code out of it, and then kind of you have to link these things together. So and if you have like 10 object files you have to link, you have to do it like repeat this thing like 10 times and then put them into this long line. And if you have make, it basically eliminates all these things to you. You just say this file depends on this one depends on this one, and then you say like make project. It produces it like figures out all the dependencies, builds all the dependencies, uses the out. This is the first time then you encountered continuous integration in your life. It's kind of the most simplistic kind of continuous integration you can have. The more advanced one is that like the next step, which looks into your code repo, and each and every time then you make a commit, it picks up your code, then looks into the make file and then rebuilds stuff for you, and you're not touching anything. On this place, on this thing, you can tell like, but wait a second, we do Python. I trust you still do Python as your coursework, right? Or you have switched to Java or .NET, or is it still Python? Well, I hope it's still Python, because I'll be showing an example in Python. Yes, you're still doing Python. If you think about it, kind of, then you are doing your Python. You still have a bunch of operations to do. Then you are deploying this online DevOps course to the site. You still have to do a lot of manual work. First, you have to get latest sources. Then you have to run unit tests, make sure nothing is broken. Then you have to deploy on staging. Then you have to run your tests on staging, figure out that staging is okay. Then you have to deploy on production, because you know it works on staging and your staging resembles the production, so you know it's fine. So it's kind of, it's still a lot of manual work, and you think kind of, we have this pipeline which looks pretty much like a conveyor. They're like you performing an operations on the next release of your software. First, like the first guy gets the latest sources, then runs the unit test, then deploys on staging, etc. And it's still manual, and like, because you are on this, under this incredible pressure that you have to deliver like every couple of days, you just don't have time for all this manual stuff. What you need to do, you need like a bunch of smart robots which will do all this stuff for you. I wonder if the guy is really still there and still causing you a headache, or we can unmute you. Is he still there? Okay. So what the idea is that we have this pipeline, and we want to automate this pipeline. We want that some kind of smart robot, which is called in CI lingo, it's called agent. It performs all the steps necessary to produce an artifact and deliver this artifact to the cloud. Master, it's kind of thing which controls agents, because sometimes you can have more than one agent working on your pipeline. Like something like that. You see, there are a lot of agents here controlling, working on the pipeline. Here you have like only one agent which performing all the steps, like moving you to the producing artifact and then putting this artifact, for example, to your cloud. And pay attention, this is asked like very often on the interview. What's the difference between continuous integration and continuous deployment? Who can answer this question? Do we have anybody who can answer this question? Let me see the video. Okay, somebody is trying to answer, I trust, but I can't hear it. Surprisingly, I can't unmute you. You can't unmute someone else, it says. Okay, we have a version coming in. Right. So this is a distinction. Like if we talk about CI and CD, then like in general case, what's happening is that this part is called continuous integration, because what you are basically trying to do, you are trying to integrate the output from all the steps into this artifact, which is called typically build, which means kind of a version, the package containing the version of the software which you can then deploy. And then you can deploy manually, or it can happen automatically. In this case, it's called continuous deployment. Means like every time you are getting your artifact, then it's picked up and getting deployment. Then it's called continuous delivery. Typically, these two things, they are coming together. So if you have CI, then you have CD, because like it makes sense to do it that way. Now let's see how does it look like in real life. I have Python project, which is basically like the pet project, not widely used now, but we working on that. So, and here I have my Jenkins server, which runs also in the cloud, by the way. And what does it do? It delivers my application to the cloud. Like what do we have here? First, let's see. Let me switch into do not disturb mode. So what we have here, we have this continuous integration server, which is called Jenkins. It's kind of one of the most popular out there and it's so popular for the like number of reasons. The first one is that this thing is really universal. You can use it to deploy .NET applications. You can use it to deploy Java applications. You can use it to deploy .NET applications, Go applications, whatever you have, it's capable of deploying it, because it has very rich mechanisms of plugins, right? And if you will look like into what is available, it's kind of you see kind of I'm scrolling on the like the highest speed I can, and I'm not even into the half of the list. So whatever you need to do, there is a plugin for that. And this is like the secret of the immense popularity of the Jenkins. Another thing is that Jenkins is like really easy to start. If you want to build, if you need to start as a Jenkins, you can always start as a freestyle project and kind of you will be up and running in no time. So what's going on here? You can configure everything what you want from this console. So this is your project called test. This is the single pipeline available. You can connect it to GitHub and specify where you want your code coming from. So you just put your repository, you configure your credentials here, and then you just specify which branch it should be looking for. So you can specify, for example, release branch here and build everything which is coming into the release branch. Then there is build triggers. So you can call them, or you can specify poll SCM and say kind of poll it all the time, and as soon as you can configure multiple steps here, you see kind of all your plugins which you are installing will be adding steps here. So you can execute scripts, you can update Jira issues, you can do like a ton of things actually right here. Then there is a post-build actions, which can be like, you can do, you can publish reports, you can update issues that they were released, you can email notifications, you can create a task for somebody to review that the build was installed and everything is fine. So kind of you can configure everything from this thing. And with the help of plugins, you can configure like it for any type of the project. The only thing which you should be aware of is that to execute the builds, you will have to have agents. Agents, it's basically like this, you remember this slide deck, we have these robots doing stuff for you. So in most cases, for the simple projects, you just need like one robot. And here I have like on this server, I have only one robot which runs on the same server, which is called master. And like all this, everything is done on this thing. If you will, if I'll go here, for example, and say like build now, which means I kind of manually scheduled the update, the build process and the deployment process. You see that what we see here, if we go into the dashboard, we will see that the agent is now running the build. And if we will look into the build, we will see that it gone through the stages. It collected the sources, it created the environment, it ran tests, and then it deployed to AWS. And if it was triggered with your commit, then you can see like which commit exactly triggered the build, and you can even go and see like what was changed in this commit. Also, please pay attention to this green ball here. The green ball means the kind of the status of the build. If for some reason, for example, if the tests are not passing, you will see the red thing here. Kind of let me break one of the tests. No, I don't want to break like tests in the real thing. Okay, then you have to trust me like on my word, because this is like the leaf thing. I don't want to kill it, right? So I'm not breaking it, but if for some reason it will fail, you will see like the failed step here. It will be in red, and you will be able to see in logs what's going on here. And also there is a kind of funny thing. If you will, sorry. If you will go back to dashboard, you will see this weather thing here. Someone from you guys calling? If no, I'll call them back. There is a kind of this weather thing, which shows the sunny weather. It means kind of all the latest builds were successful. And if your builds start failing, that it will show the weather, like first it will be cloudy, and then it will be rainy, and then it will be like the storm. So if you are seeing like a lot of clouds, it means kind of the health of your project becoming compromised. You have to pay attention to what's going on. We see that it's kind of extremely easy to start to build the project and to deliver project to the cloud, and there is a tons of projects, tons of plugins which you can use to enable this automatic building. But the thing is that at this moment you are probably reached the stage where you have everything as a code. You have your infrastructure as a code, you have your specifications as a code, you have your tests as a code, you have everything as a code. And like the thing is that the pipeline which you have, it's apparently it's not a code. It's a bunch of things which you have to configure, right? And it's kind of, if for some reason you will be moving somewhere else, you have to write down each and every checkpoint you marked and then recreate it on the new server you are running, which is not exactly the everything as a code approach, right? So this is why we typically employ different approach. If you will look into the pipeline thing, you will see that basically the your pipeline is some kind of Jenkins file which defines what does pipeline do. And here, kind of looking into the Jenkins file, I can see that like all the stages and all the things which you were seeing, they're actually described as a code. Does anyone recognize the language, by the way? So it's kind of, it's a real language. It's a scripting language. Guys who do Java probably recognize that this is Groovy. Well, I would say like JavaScript was a successor or somewhere like a, you know, a relative of Groovy, but this is Groovy actually. And what does it do? It says kind of, it declares a stage. We have a stage collecting source. And then it allocates an agent which checkouts from the Git release branch, cleans the environment using credentials provided, and talks to this repo and gets a release branch out of it. Then there is a stage creating environment which you can easily recognize. It says like prepare and activate virtual environment for the Python and then install all the requirements into it. And then it says kind of in the environment we just created and the source code we obtained, generate the tests. And then for these tests, publish HTML reports about the coverage. And then we see that this deployment stage starts. It says these credentials using this key from the credentials do the following. First, get the latest source code from the Git and package it into the source code. Put this artifact. You remember we were talking that this is artifact. It's producing artifact. It produces an artifact and puts this artifact into the S3 bucket in Amazon. And then it creates application version in the Elastic Beanstalk, which we have to discuss separately, and then kind of initiates the deployment from this S3 bucket. And then we just wait till the end of the deployment and see kind of if the deployment succeeded. If deployment failed, we failed this stage. Otherwise, we say everything is fine. We update environment in the Beanstalk. We will talk about like what does it mean in a few minutes, okay? Here I'm just like giving you the gist of it, like what's going on there. Okay, one important thing here is that we have instead of the credentials we are using, we see like very strange thing referencing some external kind of variables. What is it? By this time, you definitely remember that you should never ever hard code your password or API access keys nowhere in your application. You have to use a special kind of the key management service secure storage for your application. Surprisingly, we have this kind of solution for the Jenkins also. If you will go into the credentials in Jenkins, you will see like very special store which contains, this is not the key, by the way. You realize that, right? This is just the name of the key. So they are hidden somewhere. And these credentials are available for all the pipelines. So basically, even if I will grant you access to my private repository, this deployment section is contained, you would not be able to deploy on my behalf because you don't have access to this secure storage of ours. Okay, then kind of the next big question, why on earth do we need clouds to deploy? Why can't we just go to the corporate IT and tell them like provision server to our very specific requirements, and then we will use this server, and then we have to put this server on the network, and then we have to expose this server to the external world, and to get there we have to obtain the permission from the corporate security group. So you kind of getting my drift, right? Because like corporate IT is very often it's like that. If you are talking to the corporate IT, the simplest thing you need to deploy like application to the app, it will take like eons, because it has to be, you know, approved, it has to be reviewed, it has to go somewhere. So this is why clouds are so immensely popular, because you are getting rid of all this hassle associated with the in-house IT. But then there is kind of two flavors of IT, which is infrastructure as a service and platform as a service. And you may be wondering, like, and platform as a service is always, in the long run, will always cost you more. Make no mistake about it. Like, infrastructure as a service in the cloud will cost you more than on-premise servers. Platform as a service will cost you more than infrastructure as a service. But so why are we using that? Because there is a trade-off between the cost and the speed. And if we are talking about, even if we are talking about deploying your application to the cloud, then kind of there is a whole bunch of stuff you have to do. First, you have to configure application endpoint and configure route 33 to receive traffic there. Then you have to install the load balancer, which will be accepting your client requests. Then you have to create VPC, which all this stuff here will be living in. Then you have to configure your web servers, and these web servers, for the high availability, they have to be in the different availability zones and maybe in the different regions. Then they will be talking to your application servers, and those will be in the different application zones too, and there'll be multiple of those. And then you have to configure load balancer, which will be splitting traffic between those. And then there is a databases, and databases have to be fault tolerant. Then it means kind of you have to have multiple replicas. So you see, kind of, if we are talking about the rapid deployment, right? Like you can spend a week deploying this stuff, right? That's a problem. Even if it's in the cloud and you don't have to get through the approvals, you can still, like, if you committed to this task, you will be doing it like for the full day. So like the natural thing which comes to your mind is, can someone please do it for me? So I just want to host Python application there. I don't want to know anything about load balancers, VPCs, availability zones, fault-tolerant databases. I just want to host my Django application. And this is where the platform as a service comes into play. So you going to your platform as a service, you have your MFA enabled because you know that kind of it's way, way more secure that way. You log into your thing and then you say kind of, I want to run application. cloud. And I don't want to know anything about this stuff, right? I just want to be able to run my application. And what you do, you basically say, I just want like test application, the button is hidden. So, and then you create this application and you say kind of, this is the web application which I want to host. And then it says kind of choose a platform, and you say kind of, it can be Docker or Docker Compose application or Go or .NET or Java or Ruby or whatever you want it to be, because you can upload your custom Docker. Yep, and you just choose the platform, and then it asks you kind of upload your code. You upload your code, you choose the platform, and that's it. And it basically, it will take like 5 minutes for this application to create the environment, and then your application is up and running. You will have your the only like downside is that name will be strange, something like test, US East, Elastic Beanstalk, blah, blah, blah. But it's easily solved, this road 53. You go to your DNS server and then you map. You say kind of, I'm creating the alias for this environment. And then kind of, this is it. Then your application will be, you see, this is application which is kind of up and running in the cloud. It's in the decent domain. It kind of looks good. It does whatever it has to do, and it runs in the cloud. And the thing is that behind this thing is I haven't done anything by hand. This is this Power Grid thing running in the cloud, that it says kind of, this is Jenkins Power Grid AWS version 35, build 35. And if we will look into the into my Jenkins, which is running here somewhere, let me open it. What's the current build number? 35, right? So kind of the next thing which you do, then you have this web application environment setup. You think like, can I eliminate the last step of uploading this code manually? So you set up this stage which does like basically the following. It gets the, you see now what's happening here. So it takes your current source code. It packages it into artifact. It uploads this artifact to the cloud. It then deploys this application to the cloud. And then it updates all the changes, including like setting this build number. So then you arriving to this thing, you see that Jenkins Power Grid 35 is here. You can of course do it manually, but what's the point if your continuous integration server does it for you? So see kind of each and every commit which you are doing, saving you a lot of time, right? So it gets sources for you, it tests them, it tests them in the right environment, it packages them and delivers to the cloud, it deploys it to the cloud, application in the cloud to have like the most latest information, and it even does monitoring for you, okay? So it says kind of, I deployed new version, environment updated successfully, environment health, okay, deployment took 12 seconds, and like 30 seconds ago, application deployment was complete, like the total time was 19 seconds. So instead of kind of spending the Denis do that? Okay, we got a question. So kind of this is basically the gist of it. So this is kind of how you can use Jenkins and AWS to automate the deployment of your application. I just want to suggest like a couple of plugins which you may find helpful. The first one will be, of course, kind of it's good to, you are all working in Slack or we're working in Slack, I trust, and it's incredibly useful to have Slack integration. So you can have all the statuses and all the progress published to your Slack channels. So there is a plugin for that. So it can send Slack notifications. Then there is a very nice plugin which is called Chuck Norris, which will show you the picture of Chuck Norris, which will be showing you like the thumbs up or be like really pissed off depending on the status of your build. So this is kind of what's happening. Then the build is broken. This is what happens kind of if the build is okay. And also you probably noticed that this Jenkins thing is kind of ugly. And there is a solution for that. It's called Blue Ocean, and it's a nice, sleek, modern UI for your Jenkins installation. So you can see everything like which was there like in way more modern and way more clearer representation. So it will show you everything like and the output and everything else. So I think this is it. So the last thing I want to do is summarize, like automate integration, continuous integration, and automate delivery of your application. It will save you enormous amount of time. Use triggered builds, so kind of it will happen automatically, again saving you time. And please don't forget to not store API keys, passwords in the open. So in this case, everything will be always updated with your updated and delivered with your continuous integration servers, and you will always have like the repeatable, fixable process. I think this is it. This is all what I have for you. If you have any questions, it's the right time to ask them. But please either type them or go close to the microphone, because all I can hear is this magnificent drill of yours. Yes. Well, now I can hear you that you are talking, but I can't make a word out of what you are telling me. So people better ask you, and you send the questions, and I will answer them to the best of my understanding. Okay then. in the NAU directory, and you can always find me in NAU directory and ask me questions later on if you will figure out that you have something. Okay? Oh, thank you. Okay then, so if we don't have anything else, then I trust we are done. I hope I was able to sell you on Jenkins and AWS.